Hey guys, what I've done here is I've eliminated the need to use get and put altogether when you're creating a sprite. And let me run the program and then I'll walk you through it. So what I have here is a snake going across the screen. And, you know, it has a recoil position and a slithering position. As it goes across the screen. Use your imagination here. These are highly pixelated graphics. Okay, so the snake goes across the screen. And this is in effect a sprite. And how am I doing this? Well, I'll let you see. There's only 17 lines of code, and it's very simple. I usually, let me just list 1 to 10. I think that'll fit. So we'll walk through the first 10 lines. So I just have a screen set up, and then after that I have my graphics set up. So I put a for next loop here so that it goes across the screen and it fits, and I use step 10. It doesn't go outside the border. And I've incorporated str $ into this. So I have $1 and $$ subscripted because we need 2 of these. And what you do is you just substitute, because draw, I found out you cannot manipulate variables within draw, so I couldn't place X in here. So what I had to do is place the BM and str $ changes numerical data into string data. And so then I have comma str $ my Y value plus the semicolon, and that all goes down here. So it's draw $$ plus, and then you have the rest of the graphic in here. And the same thing for the second snake, or it's the same snake but it's 2 different positions. So they made it so that you can manipulate draw this way, at least the beginning of draw. You can substitute $$ for where the BM would be, and you can manipulate variables in the str $. I can place X in there. My starting value of 0, it's on the left hand side of the screen, and this is my Y value, and $$ takes the place of your start there, and then you just add it to the draw statement. And then I have, so what happens is it draws the snake in the I think, let's run this one more time. It draws the snake in the flat position there so that it's stretched out, and I use a green for the body and yellow for the head. And then it goes through a timer, and once it goes through the timer, it draws the exact same snake all over again, but it draws it so that it blends in with the background. I change the color to 4, and that erases the first snake. And then snake 2, or position 2, where he's recoiled, I substituted the $$ subscripted number 2 because it's different, slightly different information. And then it draws the snake in the coiled position. It goes through a timer, and then it draws the exact same image in so that it draws the same image in red, which in effect blends it into the background and erases it. And then it just starts over and it calls for next X and it pushes it a little farther over. So it would push it over 10 spaces because I'm using step 10. So it just adds 10 and it'll add 10 to that until it gets to the end of the screen. And I cut it off at 220 because the length of the snake is 10. And we only go up to 254 so that it doesn't get cut off. And then once it goes through the cycle and it gets to the end, it just goes back to 4, which starts the program over again. And that's all there is to it. So when I run the program, I get this animation of a snake going across the screen. And I didn't have to use get and put. And this is what I recommend that you use when you're making small sprites. When you're using large graphics, then I would recommend using get and put. That's where get and put really makes sense. It's not really, it's really designed for bigger graphics. I wouldn't bother using get and put if you're just doing something small like this. This is a lot simpler, even though you might not understand how $$ works. That's the only hang up here. I mean, you can understand that we draw our snake, we put a timer up, snake disappears. Sure, you can understand that. Look into $$ if you don't understand what's going on here. String values, you can add different parts and it'll all become the same string line. So for example, line 6 is really saying BM. It's really saying BM, okay, 0 plus X, then we throw a comma in, and then it's saying 100 and that. So this is what $$ is equivalent to, and like I said, with the draw command you can't substitute variables inside the quotations, so you have to do it this way. So in other words, your get and put for a draw statement is just this. This manipulates where the graphic goes on the screen. The rest of it is just draw data. The rest of it is just, you know, data that actually draws the image. The very beginning is the X and Y coordinate of the start point of the image. So we put $$ equals BM, so it ends up being here, plus $$ 0 plus X is our start point, which equates to this here. So the string data gets incorporated as numerical data, and you can manipulate it. And then the comma is right here, and the 100 is at the end, and the semicolon you need, and that's there. So $, literally, if I print $, print $, you can see what it's equivalent to right now. BM 60, comma 100, semicolon. And if I print $, subscripted by 2, which is the other value, it's just moved over 2. So that's why I had to make 2 of those, because the recoil is a little shorter than the stretched out position. So when it looks at the draw statement here, number 9, it's really saying draw $, and again, $, is equivalent to that. So if I list 9 right under it, it's saying draw $, here's $, so it's the BM that it needs, the 60, whatever the positions are, the semicolon, and then it goes on to read the rest of the data. To me, this is way easier than messing around with get and put, because your background colors don't always match, and I've tried numerous different ways. I've used preset, which works pretty good, but you still have to deal with a discretion of background colors, which don't always match your screen graphics. And then there's get and put, which, like I said, I think it's a lot better for larger graphics. It's not necessary. So even though we don't have a Sprite feature built into the computer, we can write a short app that acts as one, and it's not really that hard. So with 17 lines of code, I can achieve a Sprite feature on a color computer 1 or 2. And if you have any questions or comments, go ahead and leave those. And the other thing that I could do, and I might make a part 2 of this tomorrow, is instead of having it automated like this, I can connect it to the joystick, and we can move our snake around the screen using our joystick, which is a little more complicated, but it's not too bad. So I might take you through that tomorrow or when I get a chance. And that's the end of this video. And so take care.